Hi, this is demo 3, making a former for using in the vacuum form. So when using vacuum former, you will need to make some preparations, and you will need to make a former for your vacuum former. You could make it from a selection of materials, that is your former. You could make your former using clay, wood, foam, believe it or not, or plaster. Okay, so your former is a shape that is solid normally, and this might be a solid former shape. The ideal shape for a former is something that is quite round, doesn't have any sharp edges, and it needs to avoid having undercuts. Right, so as I've said, the ideal shape for a former, is a dome. Now, a dome is obviously a three-dimensional shape. Now, that's just a two-dimensional drawing for it. Okay, so what you want to avoid with all formers is having a shape that has undercuts. So anything that might go in near the base will be seen as an undercut. There is a reason for that, and I will just show you that just through a diagram I draw on the board. Let me just rub this out here. So this is your side view of your former. That being one with undercuts. These would be considered to be undercuts, just here. Now, if this is from the side view, your plastic, which I will demonstrate anyway, will go over this space here, and eventually you'll have your plastic formed shape, really like a mould from your former. Okay. Now, if you have undercuts, as you'll probably see as I'm drawing, if you have undercuts, you will have a shape that goes in to this space here, and you may have already guessed what might happen. As a problem to the undercuts, you will not be able to take your former out. So you won't be able to take that out once you formed the plastic over your former. Okay? So ideally, you should have a shape that is free of undercuts. So there's a shape like that, and that's why I describe, or I use really a dome as a demonstration. Obviously, as I was saying before, if that's not the shape that you want, then that's not the shape you want. You want to create a shape that reduces the amount of undercuts, because you will not be able to take the former out otherwise. Okay, so you have your ideal shape, and then you have your plastic mould that is then heated up and creates that dome shape. And as you see, you will then easily be able to extract that out of your mould. Okay. So the idea for you creating a former is so that you can actually create some sort of shell, and this is a process that's used in industry. You'll find that quite a lot of plastic products or components are either vacuum formed or they're injection molded. If they're made from a type of sheet plastic, they're often vacuum formed, but injection molding is a completely different process that requires you making a solid plastic shape. There are also other types of plastic processes like blow molding. That is a way you might produce a bottle, as an example, a plastic bottle. But in college here we only have these two processes, the two processes I've mentioned, which is vacuum forming and the injection molding. Right. Okay. So once you have your former, you can use that former, this being the former, remember, over and over again. This is your plastic mold. And so the idea is that you're able to replicate that form over and over again. Okay? Hi, this is part 2 of demo 3 using a vacuum former. Okay, so we have a vacuum former here, and this is the vacuum forming material. It's a thermoplastic, which means basically that it reacts to heat, right, and changes form. Right. Okay, so we have certain parts that I need to make you aware of on the vacuum former. First of all, I'd like to show you the bed or the platform where you would place your plaster former. You can place that anywhere really on the bed. The bed raises and drops, and this handle here that raises and drops your former or the table. Over here we have the heater that will then bring heat to the plastic. Normally the heater takes probably about 5 to 10 minutes when you first switched it on, probably more like 10 minutes to actually heat up. So you need to switch it on and wait for about 10 minutes before you can use it. We have a built-in clamp here. Now that's used for clamping down the plastic, which I'll show you in a second. You have clamps that are used then to hold the main frame clamp down, like that. Lift that up. You have a range of buttons here. Most of them are for the heater. So what you'd need to do is switch it on first of all, and the heater. And when you'll know it's on, you'll know all the heaters are on, because this heating unit is made up of 4 heaters, and they're all arranged in certain ways within that unit. You need to make sure that the button's on. When all the lights are on, you know that the heater's on. Okay, so now for the process of vacuum forming. Right, okay, this is your vacuum forming sheet, as I've shown you earlier. Can you please make sure that you take off the protective cellophane first, put it to the side. Now you'll find that the type of vacuum forming sheet that we buy has a smooth surface on both sides, but one side is glossy and the other side is matte. It has a matte finish. Right, so that's glossy and that's matte. Now you need to decide which side you're going to use. Okay, obviously if you want the outside of your shell to have a glossy finish, then you need to put the glossy up. Okay. So place your plastic sheet on the opening, making sure that it's equally spread on the frame. You can then make sure, once you've put the clamp down, make sure that you can see a bit of the plastic all the way around, because that then means that it's fully clamped down. or is fully held in this, at this point. You can then use your two clamps to fully fit it in place so that there's no movement there at all. And at that point, with the table down, you can pull your radiator over. That will take about 5 minutes or so to heat up. If it's been on for 10 minutes, it will probably take about 5 minutes. Okay, so as I've said, when you actually put your plastic in, it will take about 5 minutes. It might take a little shorter if you've got a shorter time, if you've got quite thin plastic. So the thicker the plastic, the longer it takes to heat up. And you need to get to the point where the plastic is almost like quite springy, almost like a trampoline. So you can check it by looking at it through the slits that you'll find between the table itself and the radiator. So I'm going to put the radiator over now and allow it to cook or heat up for a while, and I'll take it off and I'll show you the quality of the plastic at the point of it being vacuum formed. What you can do at this stage is move the radiator back just to check, making sure. Currently, it's set on a timer that is for a thinner vacuum forming sheet, so I've ignored that and I'm allowing it to cook for a bit longer. Okay. So just carry on checking. It's almost at that point where it's quite springy now. As you see, it's starting to spring. Right, I think it's ready now. So what I do, I pull the table up and then I flick a button here, so the vacuum, and I have my former and my mould also. So that is a vacuum. What's happened is all the air has been sucked out of that space, and to try and separate the plastic from what is the plaster former, you can use that, pushing and separating, pushing some of the air back in so that the plastic separates from the plaster itself. But they shouldn't be, because they've both got quite shiny surfaces. Take that off. Now that I've got my form created in the plastic, I can switch that off. I've done my separating by pressing that button there, and I've used the vacuum and I've switched that vacuum off, switched it on to suck all the air out, switched it off to stop that process from happening. Okay, so I can now release my clamps, lift up, and it doesn't even stick, so it comes right out and you have a vacuumed shape. There is the original. Now, you might find if you look at this former, it has 2 holes. Now those holes are quite helpful Not only do they suggest that that's where the eyeballs are, or the irises, but that's also where air can be sucked out of that space, creating a more detailed form. Okay, so the air gets sucked through that also, making sure that the air itself is sucked from that space. Okay, so that is part of the reason why those holes are there. So any areas on your form that are quite deep in comparison to the rest of the form can be drilled with holes, and that means that the air will be sucked through that hole and pulled towards the surface of your plaster itself or your former itself. Okay. And that's the result.